Greetings to all of you. This is a session where we are going to discuss about intermediate level chemistry, where basic concepts of chemistry will be covered over there. We'll be fetching for your international entrance or any competitive exam you are preparing for, JEE Advanced and JEE Mains for IIT and NIT entrance examination for technical domain. NEET chemistry for medical entrance examination. In addition, Telangana and Andhra Pradesh MCET exam for engineering stream, where again the technical stream it will be. In addition to all this, if you are aspiring for any government examination, where the competitive spirit, so where we will have a general studies question paper, where you can find general science as the common concept. The content what we are discussing over here will be very much fetching for that kind of examinations. Let's discuss about question number 1. Explain the name of following compound as per the IUPAC protocol. IUPAC stands for International Union for Pure and Applied Chemistry. As per the IUPAC protocol, here certain compounds are provided and we need to give their distinctive naming. Okay, here molecular formula, name of the compound is there, molecular formula is there, what condensed structural formula is provided. Here, methane stands for, it is a kind of alkane where you can find only one carbon with the CH4. Carbon being it is a tetravalent in nature, CH4 will be the general molecular formula. And being it is one carbon system, need not to go for any condensation over here, CH4 remains as such. Ethane, and this entire series is said to be homologous series. Homologous stands for where two compounds differed by CH2 unit, those are called homologous in nature. Methane to ethane, we can increase one more carbon so that CH4 now converted into C2H6. If you find the difference here, you can find the C2H6 where two carbons, that's why ethane will be the name, right? This is as per the IUPAC. So we can expand like this, CH3, CH3. Then propane will be there. So in case of propane, you can go for C3H8. Okay, C3H8 can be expanded CH3, CH2, CH3. Okay, so here butane will be there. Butane having the formula C4H10. And we can write it as a CH3, CH2 taken twice and CH3. This is the way butane followed by pentane, more one carbon got increased C5H12. This is the case you can notice the homologation. All the carbon atoms are increased by one unit, that is CH2 unit got increased. So that let me give the names of each and every carbon atom. For C1 you can mention methane, C2 it will be ethane, C3 it will be propane, C4 called butane, C5 called pentane, C6 called hexane, C7 called heptane, C8 called octane, C9 is called nonane, C10 is called decane. This is the way you can go for the molecular formula for the compounds as we are rising more carbons in a ascending manner. And here condensed formulas are provided. 10 carbons for decane. And if you rise more carbon, C11 we can say, C11 called undecane, C12 is called dodecane, C13 is called tridecane, C14 called tetradecane. Deca for 10, tetra for 4. So that 14 it will be. C15 called pentadecane, C16 called hexadecane, C17 called heptadecane, C18 called octadecane, C19 called nonadecane, C20 called ecosane. So here ecosane is the IUPAC name for C20H42. This is the way you can increase 1,1-CH2 group as we are descending, so that carbon chain length got increased. Ecosane is having 20 carbon chain length. So this is the systematic nomenclature provided by IUPAC in order to mention the name for these many organic compounds. Move on to question number 2. Question number 2 is collected from Cambridge Assessment International Education. 4 different solutions J, K, L, M were taken and they were tested against universal indicator. Universal indicator denotes what? It will work in the wide range of components. Whatever the compound you are testing, it will give the result. That is called a universal indicator, applicable to all the kind of substances, right? Solution, color with the universal indicator. So solutions are, how many solutions we have? 4 solutions are there. Solutions are J, K, L, M solutions are there. And individual solutions are used to give individual colors with the universal indicator. Whenever the solution J is treated with universal indicator, you can get green color, K will give red color, L will give purple color, M will give orange color, right? So these many compounds are there. The question is, which solutions are acidic in nature? Multiple solutions are said to be acidic. What is the kind of solution mixture? We will see. Universal indicator denotes the substance which used to measure the pH of multi-components. So many components, if you are checking, they will give the result. That is called universal. Universal means applicable to so many. Fine. This is the kind of series you can go with the intense red color, orange color, pale yellow, pale orange color, yellow color. So as we are moving, what happens? Acidic strength gradually decreases, and 6 to 7 will be neutral in nature. So here blue coloration. After this green color, you can appear with the blue coloration. Blue indicates the alkalinity. Alkalinity means what? Basicity of the components. As we are moving, what happens? Basic strength gradually increases as blue is becoming intense, and it is becoming violet, and simultaneously purple color is obtained over there. So the strong base, strong alkali, it will be. This is the way we can notice. Green indicates what? Neutral. Green exactly neutral. Red indicates exactly strong base, and purple is the kind of strong alkaline. Orange is the kind of acidic in nature. So that among all the acidic substances are K and N. This is mentioned with the writing. This is because universal indicator is used to put on red, intense orange, pale orange, yellow. All these are the part of acids only. So that we can say K and M are the part of acidic as per the universal indicator reaction. For question number 2, option number B will be the correct answer. Move on to question number 3, JEE Advanced 2020 question paper, paper 2, it will be an acidified solution of 0.05 molar Zn plus 2 saturated with 0.1 molar H2S. What is the minimum molar concentration of H plus required to prevent precipitation of zinc sulfide? Use KSP. Zinc sulfide is equal to 1.25 to 10 to the power negative 22, and overall dissociation constant H2S. K net is equal to K1, K2 product it will be. Product means multiplication. A product of K1 and K2 is called K net. That value is 1 into 10 to the power negative 21. If this is the data given, we need to go for the calculation. What is the minimum molar concentration to be calculated for the preparation of zinc sulfide, right? For that purpose, if H2S is ionized, 2H plus and S minus 2 can be prepared. H2S is taken, H2S is taken with the 0.1 molar. 0.1 molar 0.1 molar concentrated H2S was taken, and the sulfide ion provided with the 25 into 10 to the power negative 22. 25 into 10 to the power negative 22 will be given. 1.25 into 10 to the power negative 22 is the concentration of S minus 2, right? Then Ka is equal to product concentration by reactant concentration, right? Dissociation constant is equal to product concentration by reactant concentration. Here the products are H plus 2 coefficient is there. Whatever coefficient is there, that will become a power. So that H plus whole to the power 2, S to the power negative 2, and reactant must be H2S. So that concentration of reactant taken as the denominator, being it is a reactant. Okay. So its value is given as, so this K net value is given by 1 into 10 to the power negative 21. So that dissociation constant 1 into 10 to the power negative 21 can be taken, right? So here you know this value. Then H plus a square is known to be calculated. Then S minus 2 is known to you. 25 into 10 to the power minus 22 can be taken. H2S will be 0.1 molar, that as it is taken. Right. All the numerals are known except H plus whole to the power 2. Right. Here, if you clearly observe what happens, clearly observed. Negative 22 is there, negative 21 is there. This is left hand side, this is right hand side, so that you can cancel out these points. So whenever you can cancel out negative 21, negative 21 get cancelled. More 10 to the power minus 1 left, right? So whenever it is coming down, what it will happen? So it will taken as you can write it as a 1 by 10 as well, right? 1 by 10 also you can write. So that 0 and this decimal point get cancelled. So the entire value will become, so for your simplification, I'm saying the entire value will become h plus whole to the power 2 into 21 25 by 1 it will be, right? So what I am doing is 25 can be taken right hand side. 25 can be taken right hand side. Whenever 25 taken right hand side, numerator term will become denominator. So that h plus whole to the power 2 is equal to 1 by 25. So here we have a square, right? If you remove the square, the 1 by 25 will become root. Root 1 by 25. So root 1 by 25 can be written as 1 by 5. 5 5 is 25, no? So that, so root can be removed 1 by 5. H plus concentration is equal to 1 by 5. That will be H plus concentration is equal to 0 0.2 molar. 0 0.2 molar is the correct answer. They're asking for the what is the minimum molar concentration of H plus required to precipitate Zn sulfide, zinc sulfide. That is 0 0.2 molar. For question number 3, 0 0.2 molar is the correct answer. Move on to question number 4. Question number 4 is collected from JEE Advanced 2021 paper 2. Question paper PCM 25. Consider a helium atom that absorbs the photon of wavelength 330 nanometers. The change in the velocity in centimeter per second of helium atom after the photon absorbed is dash. The change in the velocity that to be predicted, that is needed to be calculated. Assume momentum is considered when photon is absorbed. Use Planck constant value 6.6 into 10 to the power negative 34 joules second. Avogadro number is 6 into 10 to the power 23 mole inverse. Molar mass of helium is 4 gram per mole. This is the case. The change in velocity during the after the photon absorption will be 30. This can be calculated. In order to calculate, we have the formula lambda is equal to h by m into delta v. Delta V denotes change in velocity, change in speed. If you are having some extra energy, how in what way you are speeding up your way of working, that is called its velocity. Here also we are supplying the photon of energy. Whenever photon of energy is applied to the helium, in what way its velocity got changed, that they are asking for delta V to be calculated. Lambda denotes what? Wavelength. The wavelength of light, photon light is given 330 nanometers. Let me convert a nanometer into meters by multiplying with 10 to the power negative 9. They mentioned wavelength in 330 nanometers. Nanometer is the unit of wavelength, right? So 330 can be multiplied with 10 to the power negative 9 in order to make into meters. H is the Planck constant. Always its value will be constant, 6.6 into 10 to the power negative 34. M. M value, M denotes molar mass of helium. Helium being it is a atomic number 2. So that let me double that. So 4 is the atomic mass of helium. Can be multiplied with 10 to the power negative 3. And it is a kind of Avogadro number, 6.23 into 10 to the power 23 can be taken. Here we have delta V, delta change in the velocity after absorption of photon to be calculated. All the known terms can be evaluated. Delta V is equal to 6.6 into denominator, so that it will move up and become numerator part. So that 6.6 remains as such, and 6 which is coming from the denominator to denominator, so that 6.6 into 6 into 10 to the power 23 remains as such, and into 10 to the power negative 34, right? Here we have 4 into 10 to the power negative 3. Then this will come as a denominator. So multiplied with 330, this is the wavelength value, can be multiplied with 10 to the power negative 9, right? All powers all powers, if base is same, powers are having same value, same sign, so that we can add up. But base is same, we are having different signs, so that we can subtract these values. Here also base is same, whatever powers we can add. Both the values are negative, negative only. So that after the calculation of this entire numeral part, so the delta V is calculated as 0.30 meter per second. In order to convert meter into centimeter, meter can be converted into centimeter by multiplying with 100. So it will be 0.30 into 100 centimeter per second. You can simply write it as 30 centimeters per second. 30 will be the correct answer. And this is the question collected from what we can say, absorption of wavelength atomic structure as well. It's a part of atomic structure only. For question number 4, 30 will be the correct answer. 30 is the change in velocity value, centimeters per second. Move on to question number 5, Telangana Gurukulam Degree College lecturer entrance examination. The question was collected. The percentage of atom economy for the formation of N-methyl propanamide in the following reaction. This is the ester. We can say what ester it will be. 1, 2, 3. Ethyl propanoate. This is ethyl propionate and treated with methylamine. It is the primary amine. So whenever ester treated with this primary amine, what it will do? It used to make the reaction. Here the ester bond will be hydrolyzed. Ester bond will be broken, and this NHCH3 will be substituted. This is the kind of simple substitution reaction. We can say substitution reaction. OCH3 now substituted with NHCH3, and it will be CH3, CH2, OH. Ethanol will be the byproduct. So this is the kind of N-methyl propanamide. N-methyl propanamide is the expected product. They're asking for what percentage atom economy is accounted for the compound, what we are expecting. That will be 65.41 percentage. Let me check. Let me show how to calculate this atom economy. Atom economy can be calculated by using a simple formula. Mass of the atoms in the desired product by total mass of the atoms in the product can be multiplied with 100. Being it is the percentage, we need to multiply with 100. What product we are expecting, its mass individually taken as a numerator, and whatever all products we have, its total mass can be taken as a denominator, and both can be multiplied with 100. So if you see this, the expected product is this amide. That amide molecular weight is 87. And total molecular weight, this amide and this alcohol, ethanol, both the molecular weight together is 135. 87 by 135, we have to multiply with 100, no? So that atom economy of N-methyl propanamide, after the calculation, we will get 64.4, which exactly mapping with 65.41. This is the way mass of the atoms desired product by total mass of the atoms in the product can be taken as the formula for atom economy, percentage of atom economy. For question number 5, option 3 is the correct answer. Move on to question number 6. Question number 6 is collected from organic chemistry as well, and it is the part of rearrangements. So organic reactions are multiple ways. Additions are possible, subtraction means eliminations are possible, substitutions are possible, oxidations are possible, reductions are possible, rearrangements also possible. Ring closure, ring opening reaction, decomposition reaction. So many type of organic reactions are categorized among. Rearrangements are the kind where they are having synthetic edge. So research edge containing segment is a rearrangement part. Here, this is the kind of Nar-Bornene system. Nar-Bornene is nothing but six-membered hexane, two carbons are dragged with one of the carbon, and this is said to be bridgehead carbon atom, and having two methyl. This is the kind of Nar-Bornene system with hydroxy and methyl substitutions on that. And further protonation, whenever it is treated with H plus any acidic medium, so that this whatever hydroxy is there, that will be turned into double bond. Double bond means what? Alkene, right? So that hydroxy will be removed and we will get alkene related compound. This kind of relation, this kind of rearrangement, we can say that is possible by Wagner-Merwin rearrangement. Wagner-Merwin rearrangement. How can we practice that Wagner-Merwin rearrangement? We will see. In the Wagner-Merwin rearrangement, carbocation, bridgehead carbocation will be generated. It will participate in 1,2 rearrangement. The important thing is wherever carbocation is generated, that is a terminal, that is 2 degrees. Secondary carbocation generated, shifted to tertiary. Tertiary means a 3-degree carbocation will be generated, which is highly favorable, highly stable kind of carbocation. 1,2 carbocation shifted, 2-degree carbocation shifted to 3 degree by 1,2 rearrangement process, which is called Wagner-Merwin rearrangement. Right. In order to get that one, first we have to apply the proton acidic medium. Under acidic medium, this OH will be protonated, subsequently water removed. Whenever water removed, we will get a new carbocation at this terminal. This carbocation is a secondary carbocation. Comparatively, stability plays a role over here. It is the stability of carbocation is the driving force for this rearrangement, so that this carbocation immediately shifted to 3 degree and this bond is moving there. Whatever blue color line is there, the blue line is cleaving over here and it will be expanded with this and we will get certain intermediate. This is the tertiary carbocation. Tertiary carbocation will be generated. We can rewrite this tertiary carbocation in another way as well, so that we can write like this, where bridgehead carbon can be just tilted like this, and you can get the methyl over there, and adjacent carbon atom is having another methyl with the carbocation entity, which is called 3 degree tertiary. Fine. And whatever carbon is there in between, which can be taken as the bridgehead. For our convenience, we are making like this, and further H plus got removed. We need to remove one H because being acid is the catalyst, a catalyst may not be consumed within the reaction, rather it will facilitate, it will drive the reaction fastly, right? That's the reason why. Again, we need to remove the H plus so that H plus got conserved. Conservation of H plus is possible. Whenever H plus is removed from this adjacent side, so that it will use to form a double bond over there. Subsequently, we will get alkene over there. So this is the entire reaction. You will get alkene over here, and this methyl called a gem dimethyl will be shifted into adjacent position, and in our Bornene system will be regenerated. The entire rearrangement carried under acidic conditions, and the presence of OH is required in order to make carbocation more facile. So that Wagner-Merwin rearrangement is a kind of reaction is moving towards conversion of alcohol into alkene kind of system in the Bornene under acidic conditions. For question number 6, option number 4 will be the correct answer. By this, we entirely completed the concepts what we chosen for the day, and we covered with the previous year question papers from the authorized exam sources, exam conducting sources, like highly standard international level papers we got covered, IUPAC nomenclature, Cambridge University, and JEE advanced papers taken into the consideration. MSET examination conducted by Telangana and Andhra Pradesh taken into consideration. Gurukulam exams, everything is most authorized sources, and information collected is genuine in nature, and it is really fetching for your examination what you're aspiring for. That might be any government organization competitive exam, or else any entrance examination you are striving for. So everywhere the content what we discussed is very much fetching. So that I'm sincerely requesting to like the channel, comment which part is really important, and share with the aspirants who are serious for the examinations, and subscribe in order to receive more such a kind of updates in the near future. Every time we are going to add new content over there, that can be available as a notification if you subscribe. Thank you very much for your patient listening. Thank you one and all.